how fast could JavaScript really get? First, you have your server container and it's running your whatever your backend is. Then you want to do SSR. Now you have a problem, right? Now you need two containers. And since you have two containers, you need a third to make them look like one container. So like you have Envoy stood up in front of them, right? And now like there's a JSON border between these containers. So you can't merely deploy to one or the other because it's going to be out of date. So you have to have like blue-green deploys and rollouts and gates. And if that can all just be one server that runs your backend code, then the simplicity of your app is returned. And like there's an enormous performance gain that you get. There's an enormous dependency graph gain that you get, blah, blah, blah. But simple fact is it's just simpler.
Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran Ayub, and I'm joined by my co-host and best bud, Eric Onerheim. Together, we're the two TypeScript fools. Welcome to the show. Welcome to the show. Today, we have Sam Gammon joining us to talk about Elide, which is a polyglot JavaScript, TypeScript, Python, and more runtime that is super, super fast and is built on Java. But you know what? Before we dive into that, first, Sam, welcome to the show. And do you want to introduce yourself for anyone who might not know who you are?
Sure. Hi, everybody. I'm Sam, and I'm the primary author of Elide.
Awesome. So do you want to tell us what Elide is besides just the tagline? Because I feel like you're not going to get it until you explain what is a polyglot runtime.
Our tagline has actually changed several times. I think now it's putting the Java back in JavaScript, which is like maximally offensive, right? But we joke with it a lot. And yeah, I think the idea really is, what if Node was built around one of these more modern engines that has come out like GraalVM, right? And V8 is amazing, by the way. Amazing engine. Node is amazing. Deno is amazing. V8 is frankly like a work of art, but it's inherently coupled to the web and to JavaScript because it created Chrome's rise. And that's why Google supported it the way they did, right? And so we see this as an opportunity to sort of shift over to some of these more server-talented runtimes, which, I mean, we're all using TypeScript and Node for servers as it is, right? But what if we could steal sort of some of this performance that Java has or that C++ has for these interpreted languages? That was sort of the original idea that started this project, about 4 years ago.
So if I were to like put my arms around it, the elevator pitch is, what if JavaScript were the same performance as these other server-side languages that we use today? And that would make it a lot more attractive to be like, oh, let's use JavaScript.
Right. And some of the performance we found is literally just swapping out some of the internals of a JavaScript runtime with some of the internals of a Java runtime. But you don't have to think about that, right? Like one thing we don't have to force developers to do is to write Java themselves the same way that Node is written in C++. You don't ever have to write C++ in Node unless you really want to, But it took somebody who was like this esoteric fan of both C++ and JavaScript, that was Ryan Dahl, to say, hey, what if we like built this server-side runtime? And that's where Node came from, right? And so we see the same sort of story playing out around GraalVM.
That's super cool. So we know that JavaScript, TypeScript, and Python are supported, but what other languages does it support? And what inspired that idea of being like, you know what? I like my JavaScript, but I also like my Python too. How did that happen?
So I think there's an exchange of benefits here that's two ways, right? JavaScript needs the native performance, and all the backend languages need the developer performance of TypeScript and JavaScript. And I grew up a backend developer. I've been in every language: PHP, Python, Java, TypeScript, Swift on mobile sometimes. And I love them all for their own reasons. But one thing that's consistent is when you're not writing in TypeScript, you miss it, right? And especially when you're doing like anything on the web, anything that touches UI, it's just so productive. It's fast. It's fast to run your tests. It's fast to build. And so there's this inherent pressure in Python and Ruby and Kotlin and Java to write everything in JavaScript and TypeScript. And that's not a good idea either, only because there are some cases where like native code is just better. It's a better solution. It's a better fit. There are some cases where Java is a better fit because you can reach for this enormous ecosystem in Maven and pull things off the shelf that you can't in JavaScript, right? And so we see these as things that should not inherently be in conflict. If you have your backend language and a sidecar runtime that's running JavaScript, that's sort of like this ideal case. And actually, I heard you mention on your last show that one of you had written a .NET SSR sample.
That was me.
There you go, right?
And that's the reason, or that's the motivation for me, right? So I'm a .NET developer primarily for the back end. So I'm writing C#, but for my front end, it's React and TypeScript, right? So, but I can't get them to work together to do like SSR. And it was only until recently that I discovered that someone at Microsoft had created a binding to be able to invoke the native C++ and API from .NET. And that's what unlocked the ability to be like, okay, now I can actually run React Router on the server through .NET and have it render the same thing as it would on like a Node server. And
that's right.
But the problem is that there's still that performance differential, so it's great, but it's not, it's just not like there, what I mean?
It's better than an IPC, right? Like where you had like the solutions that we used to do is like we'd have a separate node process in the same like task or
talking
on
over
the same
a JSON
server.
border or a Unix socket.
You got it.
Yep. Or those became 2 containers in a pod and then we got backend for front end, which we love to bash because backend for front end is like, I like to say it's not a strategy, it's 2 strategies, right? Because that's what it is and so much complexity in an architecture, especially like a industrial quality production architecture arises from that language border, right? So first you have your server container and it's running your, whatever your backend is. Then you want to do SSR. Now you have a problem. Right. Now you need 2 containers. And since you have 2 containers, you need a third to make them look like one container. So like you have Envoy stood up in front of them. Right. And now like there's a JSON border between these containers. So you can't merely deploy to one or the other because it's going to be out of date. So you have to have like blue-green deploys and rollouts and gates. And if that can all just be one server that runs your backend code, then the simplicity of your app is returned. And like there's an enormous performance gain that you get. There's an enormous dependency graph gain that you get, blah, blah, blah. But simple fact is it's just simpler.
Yes, exactly. So that just brings up, how do they work together? Like you mentioned GraalVM, so maybe is that a good place to start? Is that kind of what enables this whole thing to work?
That's right. It's definitely a precursor technology, the same way that like V8 had to be invented first to make JavaScript fast enough in C++ to pull it over to the server and use it there, right? And GraalVM is pretty awesome. It's also often misunderstood by developers just because it's a sprawling project of like many sub-projects. And different developers will engage with one of those sub-projects and sort of understand GraalVM in this fragmented way. But it's actually this much bigger thing, right? So number one, it's a JIT compiler. And in the most general sense, just like LLVM is like applicable to any language that you can plug into it, it is a general JIT compiler, right? And then it's also an implementation of Java. And so they have a GraalVM JDK that you can download, right? And that kind of thing. It's also this project called Truffle, right? And Truffle is a framework for implementing a language, right? And so Truffle, although it's a separate project from GraalVM, they interoperate. When they're both used together, it creates this extra effect where it plugs the languages into the JIT compiler and into the garbage collector and into the rest of the runtime pieces, right? And effectively, Truffle languages become dialects or plugins, really, to this one runtime in JIT. And that's important because if you have there's some prior art about this polyglot stuff, like, Metacall and these other projects, which are awesome, by the way. But the way they work is same as you mentioned before, to glue together sort of Node and CPython. And the problem then, of course, is if you share objects over a border and a garbage collector on one side doesn't know about it, it'll delete that and you kind of need it still, right? So it just gets very complex. And so if we understand this as mere dialects and it's really just object accesses and string concatenations and module imports, then it all gets much simpler. And you guys also asked about language support. So just very quick, the full list today is JavaScript, TypeScript, Ruby, Python. Sorry, Ruby is like in the wings, not quite yet, but it's on the way. Ruby, Python, Kotlin, Java, WASM, and then LLVM with C, Rust, and Swift is on the way as well. And we also have an open PR that's vibe coded totally, which implements PHP. And so that one's just for fun so far, but it does execute PHP. So we'll see how far that gets.
This is awesome. Could you also do like a maximally perverse like C# implementation?
That's what I was going to ask. Is that's on my that would be on my wish list. Yeah.
Yep. We've discussed C#, we've discussed Go, we've discussed Bash, which would be kind of interesting. Make so that like, and this is another thing that we see as a trend with Bun and Deno is these new runtimes have tools in them. They have builders, they have test runners, they have coverage reporting. We want to implement that to the max with all these languages, right? And so it's a very good question, is which tools we pick to keep the whole process unified, no matter what languages you pick to use.
Yeah, this sort of reminds me of going back to, because I'm a .NET developer, Roslyn, which is like what you're talking about with like a dialect, right? Because you have C#, F#, Visual Basic, .NET. They all are .NET languages because they go through Roslyn, which I think translates it to IL, intermediate language. And that intermediate language is like what ties them all together. It's why they can interop with each other. Is that kind of a way to think about it? Like Graal and Truffle is creating a dialect from all these different languages so that it's basically one language at the end of the day that Graal can then use and runs it through the runtime.
Yes, and I think the Graal team, by the way, would identify Roslyn as prior art too. Like definitely it's inspiration for some of the work they in fact, I think the everything the .NET guys did to make their runtime polyglot and jitified were a big inspiration to the Oracle teams that created GraalVM. But it's less an IR because it's not actually generating any intermediate representation. The upside of this strategy is that the truffle implementations of Python and JavaScript and so on are actual from scratch implementations of the library and language in Java, right? And so the native image compiler can see everything and has full visibility into everything you're doing in all languages. They're clean room implementations that are spec compliant and tested against a certain version of JavaScript or Python. They have the horsepower to do that. And so the language implementations are written at Oracle for their database, but that's all they use it for. And so they leave it on the ground for developers like us, right? Just like Google did with V8, and we can go out and solve all these cool problems with it. And so, and Oracle, by the way, loves it. They one cool thing to mention, just because Oracle has this crazy reputation, like they've opened this technology up totally. Like they've issued a new license, they've taken all their enterprise features and made them free. So Oracle, quite to the contrary of their reputation, is giving this technology away. And we understand like the hesitancy, right? But it takes a Goliath like that to write something cool like this, you know.
This reminds me of, I didn't realize it was for their database integration. It must be for like their stored procedures. You can write stored procedure in any language you want as long as it compiles in Graal.
Yes.
That's kind of like how Postgres has that same thing, but it's done through extensions. And I imagine a very different mechanism. It's probably not doing something like this where we're compiling it into a VM bytecode to evaluate, but maybe we are.
Well, if you write it yourself and link it, yes, it certainly will, right? But yeah, exactly, right. And Oracle Database, by the way, is insanely cool. Like I know it's not the kind of thing that I can ever use because I'm an OSS dev myself, and like I've never had a license, but they do wild stuff. And so the fact that we can sort of sit at the bottom of that and get some of the tech and just do the last mile here to make it usable for developers is an awesome privilege, and position to be in.
That's super cool.
Well, the language that probably our listeners are most interested in is TypeScript itself. And we want to talk about how does it work to like import a Python file and then use it in TypeScript. But do you want to talk about how that is built from the ground up?
Sure. So I should say first that we are written in Kotlin mostly, not Java. It's all like roughly the same because TypeScript is to JavaScript roughly as Kotlin is to Java. And so it solves all the problems in Java, right? Like it solves the null issue, and it's a much more fluid language to work in. So we're written in Kotlin, and just like Node does with C++, we implement the CLI, we plug that into the raw JavaScript engine, and then we implement everything underneath that you expect there to be. Because it turns out in a raw JavaScript engine, you don't get things like Node.fs and Node.path, right? Like those are APIs that are added just in Node, right? In fact, if you've ever created a Cloudflare worker without sort of being familiar with this problem, you've run into it before, right? And so what we want to do is be compliant enough with the Node API, just like Bun or Deno, so that your software runs. Lots more people use Path or FS than use Cluster. And so those modules are actually implemented with the JDK. So when you're doing, let's say, read file sync from file system simple function, that's actually using Java's NIO library, right? And NIO is well tested on like 8 operating systems for like 30 years. And so the benefit that we have over like a Bun or a Deno is that they have to implement that for each operating system, right? And they have to do it in native code, which involves like syscall tricks and esoteric system interfaces that are like have to be perfect. We just use the JDK and it's fast and tested. And so when you're using read file sync in Elide, you can trust it. It's not a new implementation of reading files. It's a well-tested implementation of reading files. It's just doing it in the API form that you would expect from the Node API. Does that make sense?
Yes.
Yeah.
Yeah,
No,
and you mentioned, I think in the docs that it is you're targeting winter TC, and we've kind of talked a little bit about this in the compiler runtimes and funtimes episode, but what it is trying to do is solve that problem between all these different JavaScript runtimes and unifying an API interface you can use on the server. So like worker D is used by Cloudflare, Deno, is Deno, Bun is Bun, Node is Node. Wouldn't it be cool if you could have like a standard API interface that just works on the back end? And that's kind of what Winter TC is trying to do. So it sounds like you're trying to be compliant with that. So how is that going?
So I'm an invited expert on the technical committee for Winter TC. Love this group of people. They're super collaborative and really just want to make this a productive experience for developers, right? Like I think if the APIs are normalized to a certain extent, then we're reducing the risk of trying these Nouveau runtimes. And that allows us to safely use these things in production and then back out and use Node if something doesn't go right just yet. I think it's a critical thing for us to support to move from sort of build time benefits, which are really low risk, to runtime benefits, which could be high benefit but high risk, right? And so it's very important work. We're shooting for full TC, Winter TC compliance. I think we're like 40, 50% there. But for us, it's not just Winter TC. I think we have a philosophy of meeting developers where they are. And I don't want to call anybody out, so I won't. But it's tempting, right? But inventing APIs is not our job. Like, as gross as the Node API is, it's worked. Like, they have functions they deprecated in Node 1 that are still there. And that's evidence that it works, right? And so we're not going to invent a new Node API. We're going to implement the Node API that you guys want, that we all want. And we're not going to invent a new server interface. What we're going to do is, and I think this actually just landed and it'll be in the next version, is we support Cloudflare's export fetch. We support Node HTTP, HTTPS. We support all the interfaces that you might want without going toward like supporting the Bun or Deno global, because that's, I think, a step too far, right? But yeah, and then where we need to, where we absolutely have no choice, we invent some APIs because, for instance, Elide has an embedded inference engine, which is pretty cool. So it's Elide :LLM. You can import it. You can, any model off of Hugging Face that works with GGUF format, it'll download it and run inference on it on your computer.
Wow.
So no API key, no remote call, no network errors. Now, obviously, like where we are today with models, you can only really run smaller models unless you have some insane hardware. But we know that window is going to grow, right? And so having a local LLM there, even if it's just for mock testing, so that you don't have to pay for calls when you run your tests, this is the kind of thing where we might have to invent an API, right? Yeah.
Would this be a thing that you could deploy to your software using Elide? Like you deploy a model with a Hugging Face model. Say, I really need my cats to be, identified in pictures, and I would like to deploy a service in Elide to find all the cats.
Absolutely.
That's what I want to do.
The way that, we want you to find every cat, right? And like the strategy we see here is you're trying to build something, and LLMs are one new component, just like anything else, in your toolkit to build something. So you need a way to test with that. You need a way to develop with that cheaply, quickly, with a quick iteration cycle. And then when you get into production, if you want to swap that out for a remote adapter and use OpenAI or Claude, great. That's fine. Or if you want to use local inference with H200s and your own copy of 70B, it's not up to us to gate that as a developer and charge you for it. We're inherently, I think, a developer experience and productivity company, and sort of everything flows from there.
Awesome. One thing that I was thinking about as we were talking about like the polyglotness, I feel like there's like idioms across languages that might not translate, kind of like in human language where there's like an idiom, like an English idiom, like I'm down in the dumps, that does not translate to like Spanish very well.
Right.
Literally, it doesn't make any sense. And literally in English, it doesn't make any sense. So like, a concrete example would be like, well, TypeScript has these, by extension, JavaScript has like promises and async await. Like, how do you map those idioms across languages? And like,
great question.
Are there any barriers where it's just like, this is just not going to line up?
So they have this thing in Truffle called the Interop protocol. And this is basically how they solve this problem. It's actually exactly how you might think they would solve this problem, which is when you're implementing a Truffle library, if you opt in to language interop, which you don't have to, if your language just can't do it or you haven't implemented it yet, that's fine. So some languages, for instance, like Pickle, don't implement that. I don't know if you guys have seen Pickle, it's for another day. But anyway, the Interop protocol specifies things like, here's what an object layout looks like. Here's what a string is and the encoding that's used by default. Here are the number types. And it's using Java's type system as like this common substrate, right? Mm-hmm. And Java's type system is pretty sufficient for this. Like it's not as rich as, say, C++, where you can have like unsigned integers and all this other stuff, like specifically sized uint8s, right? Java can't do that, but long and int and string and so on are enough, it turns out. And so that's the primitives and sort of the objects, right? Iteration and primitives and objects are sort of all obvious because they all behave roughly. In fact, languages have been stealing from each other for like decades, right? Mm-hmm. And so it's not surprising that you might be able to map between all of those. When it gets to async, Java has this fundamental concept called futures. And futures, I think, don't quote me on this, I think they predate promises. So they may have been part of the inspiration for promises too, because futures behave very similarly. It's a generic object that just promises a future value. Mm-hmm. But it's not called a promise, it's called a future. That's it. So building around that, an async function in Python and an async function in JavaScript, both for us produce a future. Same as Kotlin or Java, right? And so we use these Java execution facilities then to satisfy that and make it coherent. But it's all async tasks to us,
Cool. Do you ever like run into like with that, like if it's like say like there is like a particular quirk in a language, especially I'm thinking about like microtasks in JavaScript and how like the Java execution in Graal might be different. Like, do you have to simulate that in a way, or do you just have to live with the fact that like behavior from like a timing perspective is just going to be different, and you just that's the deal?
So you are right that there is at least one inherent mismatch between some of these languages, and that's, are you multi-threaded or not? Mm-hmm. Right? Like JavaScript's not, Python, well, not with a star, right? Like they're working on it, but right now it's effectively mostly single-threaded. Ruby's single-threaded. Java is multi-threaded. And so you make a choice when you start the runtime. Do you want the multi-threaded piece to lead, or do you want your single-threaded piece to lead? And so we can adapt to that. We can actually run Java with restrictions that forbid it through Graal's sandbox to start threads and processes. So that's a choice that we leave up to the developer, and we hope to make that like a clearer, easier to configure choice, but it's not necessarily something that we have to pick one or the other all the time. You
guys have really thought about this.
Yes, we have. We have years,
Yeah. That's so cool. Like that.
Thank you.
I could definitely see that being a problem. Like if you're like porting software and you're like, well, I have a specific, there's, like arguably if you have specific timing characteristics that you're depending on, that's maybe a bad sign, but also legacy software.
Yeah.
Yeah. And I mean, I would say that single threaded is not always like a bad thing, especially for complexity, because I've certainly run into multi-threading race conditions with like .NET, and it's always a huge pain to like work through those. So there's I mean, Node rose to prominence because part of it was because the single threading is simple, But I think what this seems like what it could enable you to say is like, I want to run my SSR concurrently with multi-threading. And you could do that because you've got that choice to, instead of running single threaded, which is the only choice you have with Node.js or Dino or Bun. And now with Elide, you could say, no, I want to actually have multi-threading for SSR concurrency. I don't know.
Now let's talk about that.
Yeah.
Because
tell me why that's a wrong idea, or could that actually work?
It's not wrong. It's just I would rearrange the words a little bit because let me explain. So V8 has this concept of isolates, and an isolate is essentially like your JavaScript execution context, right? And so in Node, there's often one isolate effectively. I don't know the internals of Node's code base, but basically it's running one thing, right? Whereas if you think about worker D, there's many thousands of isolates that are all stood up concurrently that are all running different user code, right? And so the isolation boundary is around that V8 isolate. GraalVM has a very similar model, which is it's just called a context in GraalVM, but it's the same thing where we can have a context here, context here, context here, and they all have different guest code and we're running them. And so our version of what multi-threading looks like for a JavaScript app, a pure JavaScript app, would be we stand up like 8 contexts and run them on each CPU. So effectively, each context is single-threaded, but you're running the same thing as what would be like 8 processes that are multiplexed to satisfy your server, right? And this is possible because the memory safety guarantees between GraalVM contexts are so strong. And so that's how we hit, like, we're on the Tech and Power benchmarks, for server performance. We're at 133rd above Deno, above most Java servers, most Python servers, right? And that's why is because we stand all those up, and the engine is still actually caching the JIT across all those engines, which is those contexts, which is cool, but it preserves safety guarantees between them.
Yeah, and in my work, the way that we've scaled Node is through a similar, I don't know, in at least where we are, we call it web gardening, where you have you have multiple node processes behind like a load balancer or even in one container to simulate this, multiple threads. But that's cool. That's cool. They just built in web gardening.
Yeah, right. And you can choose, I think, I don't know if we've surfaced the parameter yet, but you can choose how many contexts to start up. And we can tune that based on the number of CPUs and so on and so forth. But it's, and you might argue it's unfair, right? But if the runtime can't safely do that, that's one advantage that we get from our engine choices, that like that's a safe thing that GraalVM can do.
Yeah, that's super cool. Like, Now I'm just like I keep picking at it. So in a single execution context in Graal, can you have like different, like, could you have Python and TypeScript living in that one execution context? Yes,
but keep in mind that anytime you introduce a single threaded lang into one of those contexts, the whole context becomes single threaded. And so we are working on ways, for instance, to like execute your Java multi-threaded backend and your single threaded thing in a different context and line them up. But that's a lot more complex. And so, and frankly, most of our audience, like today, everybody's targeting serverless, right? And in serverless, you don't have access to threads. And so it's almost like the Java people even are like, turn off my threads, please, so I can use Cloudflare workers and all these little hosting services. So we get less, interest in multi-threaded stuff than you might think.
Yeah.
That's all.
Well, now you've piqued my interest on serverless because I have a lot of strong opinions. One of the things that you might want in serverless is to like thwart the cold start times by doing like ahead of time compilation type stuff where you just have your bytecode ready to go and no JIT, because there's no time to amortize the cost of a JIT in a serverless situation. In fact, you don't want to boot the JIT at all because it would be a waste of time. Is there something like that in Graal or in Elide?
Yes, there are several ways that we can make that. We have an interesting performance story there. So first thing I'll say is we are working on a new release that's going to improve startup time quite a bit. And we can get to a place that's pretty competitive with like Node and Deno and V8. Maybe not Bun, because I have no idea what tricks they're pulling for their startup time, but it's like microseconds, so we're not going to shoot for their level just yet. But there is a mode where you can turn off the JIT in GraalVM and stay in pure interpreted mode, which can oftentimes be faster. We also have a mode similar, but not the same as Bun's single file executables, right? And I think Deno and Node also now have introduced this feature, but ours is different because essentially what those do is they concatenate a copy of Node or Bun or whatever's building it and your main entry point and a bundle of all of your dependencies so that it can find them at runtime, right? And then it puts it all in a big image and runs it. And so you effectively, just like Chromium and Electron, you get a full copy every time, right? Elide can build end user binaries that are themselves compiled with Graal. And these actually do a lot more of what JavaScripters would call tree shaking, but in native code, where we're removing the parts of the runtime that you don't use provably. Graal's AOT compilation abilities are incredible. And so this feature doesn't yet support JavaScript and Python and so on. We're getting there. Today it's just Kotlin and Java, but we can produce end user binaries that are like significantly smaller and more optimized than Elide itself. Right. That will be very interesting because it's genuinely a new deployment model for lots of these interpreted languages where you would not have Python or Node in the container. Right. Yeah.
Now we've pulled this trick with like using QuickJS, and basically we're deploying C code. And QuickJS has its own like compact bytecode format, so we run it through and produce a bytecode binary. And then it just boots that and starts interpreting the bytecode in QuickJS, which is extremely fast.
Insanely fast. Yeah.
You know, speaking of performance, let's talk a little bit about the performance of Elide, because I feel like my favorite little pithy tagline that you have is that Elide can run your TypeScript faster than Node can run JavaScript. And I feel like that is, boom, that is a punch right there. That's great.
Yeah, that's cool.
Yeah.
How?
Well, I'll tell you how. Firstly, GraalJS, all credit to them because our underlying JavaScript engine is really fast, right? And I think an isolate, a GraalVM context with JavaScript in it boots in about 3.4 milliseconds, which is really, really fast, right? And so they've been doing a lot of work upstream to make our job easier. So JavaScript boot, I'm explaining this TypeScript answer with JavaScript boot because, of course, running TypeScript involves running JavaScript ultimately. And so that's the first answer. The second answer is that TypeScript on top of JavaScript is almost zero cost for us.
Yeah,
almost.
That boggles my mind. Can you explain that?
Sure. And this is actually a trick Bun has also pulled and Node is pulling now, which is to strip types, right? And so the internals of Elide is actually written in Kotlin and Rust. So the native components of Elide are written in Rust, and then we glue those together. And we found this to be a good fit because the strong memory safety guarantees we get from GraalVM fit well with Rust when we extend it. And so in Rust, we use OXC.
Hey,
there you go.
So it's actually OXC. We picked the fastest TypeScript stripper we could, the parser and stripper, and we integrated it with GraalJS. And so that means you're using essentially the same internals as Vite to parse the TypeScript. And then we throw away the types as we go and feed that right into the JavaScript engine, right? And so effectively, you're reading JavaScript as you read your TypeScript, right? And GraalJS is none the wiser, and we get really fast execution. There you go.
Do you have Evan Yu on speed dial being like, oh, we're running into this bug with OXC. Can you fix it?
I love the work they're doing. I cannot say enough about them. They're great guys. They've listed us on their website, and we're very thankful for that. We talk to them all the time. And I think they're creating space for this modern tooling revolution. It's not just them, it's UV in Python, and there's an equivalent in Ruby and PHP. And I think anything that saves developers time is great news to me.
Yes.
That is pretty cool.
So should we get a little bit practical too? Of like, as a TypeScript developer, I'm very interested in this now. Is this something I can pick up today and just start building an app? Like, where's Elide right now? And what is the app dev experience with it right now?
So we've just recently gotten funded. We're going to be around for a while.
Awesome.
We've got a new office in San Francisco. We're hiring. We're building as fast as we can. And we're at this stage as a startup where we're going from the code base that made the idea work to the code base that we can go to war with, which is a different code base, right? And so we've got much stricter performance engineering that we're putting into it and strictness in every regard. And I think when that release comes out, we're going to call it stable. It's in beta right now. And so you can try it. It does work with HTTP. It works with our LLM stuff all works. SQLite works. Most of the Node API file system works. In fact, we've been able to build most of Elide with Elide. We're getting there too. That's a project we have. So yeah, exactly. Just nested layers of abstraction. So it's getting there, right? And I think maybe in 6 to 9 months, it'll be stable enough that you could go to war with it, either as your dependency manager or as your runtime, right? And the thing is, when we're done with it, it will be stable because, like I said, it's building on all of the lessons that Java already learned. And so on Windows, on Mac, on Linux, it's going to be hopefully very stable and performant by the time we get there.
That's cool.
That's super cool. That's an excellent prognosis. I mean, being built on Java that has this battle testedness is such a good strategy in my opinion, because you want to pick something that has a good solid foundation. One thing that piques my interest in like a local developer situation is like, how do you debug across these multiple language boundaries?
Mm-hmm.
Like I'm in my editor and like what happens when I step into some Python code from TypeScript? Like, is my mind going to be blown? And like, what's going to happen?
So let me blow your mind. And I'll take it one step further too. And we'll talk about the implications of sort of this VM that's general, right? Because this is a new thing and it sort of uproots lots of the paradigms. There's like lots of second order effects that simplify because of it. And this is one of them for sure. So GraalVM and binaries made with it by extension Elide support several debugging protocols. They support Java's debugging protocol. They support Chrome's debugging protocol. Yeah. And so you can actually boot up Chrome's debugger just like you would for a Node backend app.
No way.
Get ready for this. And you can step through across no problem languages.
My God.
Chrome's viewer actually doesn't care what language your source is in, right? So if the VM it's talking to tells it to go to a line in a source file, it will, and you just get a regular debugging experience.
Hold on, because you know what this means, right? Is that I could just use VS Code, because doesn't that just support the Chrome debugger? Yeah.
That's right.
Yeah.
That's right.
Sweet.
Yeah.
So I can just press F5 in my VS Code and I get my native debugging experience.
And we don't yet have a VS Code extension. We're working on all this stuff, but that's exactly right? That's the experience we want to give you. Is it's just stepping through code. It's so much simpler of an answer than you might think, right? And like, here's one more, just because I promised that there would be one more. Coverage. How does coverage work most of the time in languages? This is so silly to me as a programmer. It usually works in many languages by building in lines of code between your lines of code that are injected there to say, hey, I just ran that line of code, right?
Mm-hmm.
And so you actually have to change the program you're testing to instrument it to see what was covered. And that's a source of all sorts of headaches downstream. How do you report accurately about coverage? How do you map lines to the files? I'm trying not to swear, to the files that those lines originated from. And by the way, forget it when it comes to cross-language coverage. I think there's probably like, who actually knows their end-to-end coverage from Python and JavaScript or something? Nobody, right? And so GraalVM, it's one of the things they built along the way, is that the VM knows what it executed, and we can just ask it. So
that's cool.
So cross-language coverage is something that we can support out of the box. Yeah.
That's awesome.
Yeah, no longer will I be configuring Istanbul.
That's right. No Istanbul, no JUnit, no, there's so many. Yeah, Jacoco. I mean, I'm naming Java frameworks now, but like coverage is a pain in every language, right? Yeah.
So you sort of teased that a lot of second order effects get removed with this polyglot runtime-ness. So, I mean, one of my next questions as a developer might be, when would I use this? When I primarily might work in TypeScript, should I be thinking about just switching to this? Like, in what use cases does the polyglotness really shine? What should I be looking for there?
I would say that our original reason for existing is the same reason you built your .NET prototype, which is backend apps that want to access the brilliant UI in React and those kinds of libraries without giving up either the code they've already written or the code they intend to write in that backend language, right? And that's a technical and a cultural problem. Like, this allows front-end and backend teams to use each other's code, right? Which is pretty cool. They couldn't do that before. So that's number one. Number two, later, I think, will be tooling, right? We're working on our startup time stuff. And once that's down to like a comparable level, I think building tooling with the access to like the Java universe and all the other dependencies that you can pull, because by the way, Elide is a polyglot dependency fetcher. I don't know if I mentioned that. So it'll fetch from Maven, from NPM, we're adding UV because you're going to need one, right? Like if you have all these languages and how many Python code bases have a node modules folder? Like so many, right? So if we make that one tool that can install really fast all the dependencies that you need across languages, we're going to lower the barrier here of having to pick, or I guess the cost mentally of picking the language that you actually want to use. Right. So, does that answer your question or did I rant? I can't tell.
No, that's good.
That's perfect.
There's actually a very recent use case where I needed to introduce multiple technologies, and that was in my MCP course where I talk about a lot of enterprises use Java and .NET to do backends, and MCP servers are essentially backend servers, but most of the ecosystem is all Python and JavaScript or TypeScript, so you actually end up needing the Node.js runtime, the .NET runtime, the .NET SDK, in order to install like the MCP inspector so that you can then run .NET run, the run command, which actually boots up your .NET server, so like,
right.
That was just recently, like in the last few weeks, I ran into this. So it seems like there's a lot of opportunity there.
Absolutely. And look, Bun was the shot heard across the bow with their dependency installer. I don't know, I'm mixing metaphors there, but you get my point, is that like that was a big deal. And I think this is one that we can take on because I don't think Bun or Deno or any of these guys like have an incentive to help the Python or Ruby or whatever people. And that's fine. Like they think JavaScript's going to eat the universe. More power to them. They're going to serve JavaScript. Nobody's doing anything for everybody else. And that's the area that we're intending to target.
Well, and you get a third mover advantage on package systems because everyone's done it wrong at least twice. So you can take advantage of all of the learnings that have already happened and really provide a first-class experience.
I'm a student of history. Oh, yes. And I've watched it with joy. I think this is the kind of competition that's inevitably going to create a better experience for us, right? And so I love the guys Bun. I love the team at Deno is great. All of this work is good to me.
Yeah, I think I mentioned this before, but I recently read This is Strategy by Seth Godin. And one of the takeaways that really stuck with me and what I see here is he's saying, go where your competitors will not go. You want to go to the edges because Bun and Deno, they're not going to go here. They're not going to create a polyglot runtime. But you guys are. And you may be the only ones that do that.
And by the way, they may argue that you can run Python on WASM, which is true. But like, do you want to? It's not fast. Like you don't get anything that you expect with, your standard library. And so patches like that, I think, are patronizing to developers, right? Like there are true advantages to these languages. And one of the advantages, by the way, is just that it's easier for your brain to use. That's totally sufficient. Is that like if you're a better coder in Python, you shouldn't feel this pressure not to write Python. Just write your Python, right? And like
exactly.
And like work with the TypeScript people, and we can all go home and have a snack and end our day, right? It's like this doesn't have to be a dogmatic battle anymore,
So
that just tickled my brain in a type system way.
Yes. Actually, that was my next question, which is like one of the reasons I've given for using C# on the back end is I get my runtime types. And I feel like we're seeing this kind of trend of developers wanting some kind of runtime type system for TypeScript, but we're not getting it with the current engines. Is this something that Elide might offer in the future? Like how are you guys thinking about that?
We think about this stuff all the time, including what would it look like if we wrote a native truffle engine for TypeScript. And it is true that a JIT compiler can often, the stronger an assumption it can make about your code, the better it can optimize it. Knowing types is a pretty big enhancement to the visibility that the compiler can have into your program. That's kind of like very far future experimental work today, just because, it's hard. There are a lot of question marks. TypeScript has never really been run, ever. It's compiled into JavaScript and then run, or stripped of types and then run. And so there might be places where we would have to violate language rules or something to actually ship that, right? I don't know. But we're thinking about it. And that's the thing, is it is possible in truffle. So that's the kind of thing we'd love to collaborate with the community on. If there's somebody who wants to go find out what kind of performance benefit that would deliver, we'll help you. And Elide it's modular, can ship those languages with the core later, right? And so this is a concept that can grow.
That's cool. Obviously, you want to get the foundation laid first before we talk about the pie in the sky stuff. But I feel like that's like a far future thing. I'm super, super interested to see what shakes out.
We dream about it all the time, and I wonder like how fast could JavaScript really get?
Yeah, and to Kamran's point there, that might also shift you into like that's not quite TypeScript anymore, because you're not a superset of JavaScript anymore. You're now a different thing. You're like a subset of JavaScript that is sane,
right?
That you can rationalize with types.
No, we've talked to the Kotlin guys about building a Kotlin VM too, because they have the same thing. And when your language is behind another language, it inherently adopts all of the drawbacks and benefits of that, right? So it would sort of unchain TypeScript in a way that would be hard to calculate the effects of. But it's all stuff that's possible with Graal, and that's what's beautiful to me, is that if we're going to create a new runtime, let's pick an engine that really unlocks that future ability.
That's super cool. What takeaways do you have for the audience? Where can they go to learn more about Elide and play with it, at least to get a taste of what this new experience might be like?
If you like this idea and want to follow it, star it on GitHub. We count those every day. The developers literally will cheer. They refresh the page and will cheer when you do that. That's number one. And number two, download it, use it. Tell us what fails, because we have this sport of fixing bugs the next day and shipping a release. We love to do this. When somebody new finds us and reports an issue, we fix it and turn it around the next day. So like, try us, right? And then I think bring your ideas. If there's a future that you want to see that this unlocks, we'll clear the way to let you build it. We'll help you build it. We'll build it ourselves. I think whatever gets us there is what we're after. And so I know they're out there. I was a backend developer myself, and I was graded at me for many years just how great TypeScript was. And then finally, I just joined them, right? I decided I had to. And this is the logical conclusion of that, is that the lesson of Node was that a single-threaded JavaScript runtime is incredibly useful. So put it into everything else.
That's right.
This is so cool.
That's the perfect note to end on. So thank you, Sam, so much for joining us. Where can people go to learn more about you specifically and what you're up to?
GitHub.com/sgammon or Discord. Actually, that's the other thing, is if you go to elide.dev/discord, or you run Elide Discord in the binary, it should give you a link to join our Discord. And that's where we all hang out. Like, everybody who writes code on this is there every day. We will chat with you guys. That's what we do.
Perfect.
So if you want to find me or anybody on the team, that's where we are.
Awesome.
I totally just joined the Discord.
Yeah, right on stream. Perfect. I'm in there too. Yep, that's where I posted initially, and then how we got to this conversation. So obviously, me and Eric are super excited about this. So we will keep our listeners informed when there's new developments with Elide, and we're really excited to see where you guys take it.
Well, thank you guys for having me. We're a small company, so we just love getting noticed. And by the way, the marketing guys have heard your message that we need better marketing. We turned it up and made them listen, right? And so
Awesome.
that will be coming soon too. So thank you guys for having us, and we're an open book. If you want us back, just let us know.
Perfect. We probably will
Awesome.
have you back after the 6 to 9 months when it's out of beta.
Got to hold myself to that now.
That's right.
All right. Well, cheers, guys. I got to jump.
Awesome.
Awesome.
Talk soon.
Thanks.
Thank you so much. All right.
Thank you. Bye.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to typescript.fm, where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at comronicus.com, and Eric is at ericonerheim.com. You can also follow the show directly at typescript.fm.